right, so as you are studying for your 4 to 6 quiz, I'm going to go through all of the problems here and just work them out. So feel free, if you only had questions on one or two of them, feel free to kind of fast forward if you can to the part that you actually have a question on. I'm just going to start at the beginning and work all the way through. So, number 1 through 4, we want to factor completely. So first thing we always do when we are factoring is look for a GCF. And on number 1, the GCF is 2x. So I factor the 2x out in front. Remember, this is like reverse distribution. So what do I multiply 2x by to get 2x cubed? I'd multiply by x squared. Do the same thing here. What do I multiply 2x by to get 10x squared? I would multiply by 5x. And then 2x times 4 is what would give me 8x. Remember, whenever you do GCF, you should distribute it back out in your head to make sure that it's right. When you multiply this 2x times each of these three terms, it should give you back your original. If it doesn't, then that means you've made a mistake. So we need to factor completely, so I need to look at this trinomial that's left and see if I can factor it further. At first, I might think that it is a special product because the square root of x squared is x and the square root of 4 is 2. But remember, a trinomial special product would have to be a PST, and the middle term would have to be double these square roots multiplied together. If I multiply those together, I get 2x, and if I double it, it's 4x, not 5x. So this cannot be a special product, which means this is factors that add. So I'm looking for what multiplies to 4 and adds to 5. So that would be 1 and 4. So that means I fill into my parentheses x plus 1, because it was a positive 1, and x plus 4. And this is my completely factored answer. All right, next one, I look at number 2, and I do not see a GCF. I look quickly for special products, but 3 and 10 don't have perfect square roots, so I can quickly dismiss this and find that this particular one has to be a split the middle. So when we're splitting the middle, it's what multiplies to AC. So 3 times negative 10 is negative 30. So I'm looking for what multiplies to negative 30 and adds to negative 1, because that's negative 1x squared. So the factors that multiply to negative 30 and add to negative 1 are negative 6 and positive 5. Remember, this is split the middle. You don't just fill the answers in like we did over here, because this was factors that add. On split the middle, we split the middle term into these two things. So first term stays the same, 3x to the 4th. I split the middle term into negative 6x squared plus 5x squared, and then bring down my last term, minus 10. So now I'm going to factor that by grouping. So here's my first group, here's my second group. So the GCF of this first group is 3x squared, gives me x squared minus 2. If this parenthesis is x squared minus 2, this one has to be the same. So work backward. What do you multiply x squared by to get 5x squared? You would multiply by positive 5. So that means my factored answer, my first parenthesis, are these fronts. So 3x squared plus 5. And my second parenthesis, the back, x squared minus 2. Now I would look, since these are squareds, to see if these factor further, but this is not a sum of cubes, and that's the only possibility. This is not a difference of cubes or a difference of squares, so there's nothing else I can do with those. So that is my final answer. On number 3, first thing I should look for is a GCF. But as I look at them, there's nothing that divides 16 and 81 evenly. So I look at special products next. Since this is a minus, I look to see if it should be a difference of squares. So I look for square roots. Square root of the front is 4x squared. Square root of the back is 9. And since it's a minus, that means they both had perfect square roots. So this is a difference of squares. So 4x squared plus 9 and 4x squared minus 9. Now, every time I factor, I have to look to see if it factors further. These two did not. However, this one does. This one factors further because it itself is a difference of squares. The square root of 4x squared is 2x, and the square root of 9 is 3. So that means bring down the first parenthesis. That does not factor further because there's no such thing as a sum of squares. So this stays how it was, but this becomes its own difference of squares. So 2 parentheses. The 2x square root goes in the front, 3 goes in the back, and then one of them's a plus and one of them's a minus. So there we go. For our final factored answer, none of these go any further. All right, last factoring one here. 16x cubed plus 250. So I look for a GCF. They're both even numbers, which means I have a GCF of 2. Leaves me with 8x cubed plus 125. So I look at what's left to see if it could factor further. This does not have perfect square roots, so it can't be a difference of squares, and it only has 2 terms, so the only other thing I could do is sum or difference of cubes. So I looked, does 8 have a perfect cube root? Yes, it's 2. Cube root of x cubed is x, cube root of 125 is 5. So, because both terms had a perfect cube root, that means this is a sum of cubes, the SOAP. So SOAP factoring. So I bring down my 2 GCF that needs to stay in front. When I SOAP factor, it's always a binomial times a trinomial. So one small parenthesis and one big. In the small one, I just fill in the square or cube roots. So 2x was the cube root of the front. 5 was the cube root of the back. When I use SOAP, it stands for same, opposite, always, positive. So the sign in my binomial is the same as the original, so a plus. The next sign is opposite of the original, and the third sign is always positive. So now, once I've got this binomial, the trinomial here is based upon the binomial. So I look at the front of the binomial and I square that, and I put it in the front here. Middle is multiply, so multiply these two together, which gives you 10x. And then finally, to get the back, square the back. 5 squared is 25. So I had previously said whenever you factor a sum or difference of cubes, this binomial will not factor further, ever. So you don't have to do anything else with that. That's as far as I can go. All right, so now we factored. Moving on to finding solutions by factoring. So that means factor first and then solve. So on number 5, I look and there is no GCF. If I have 4 terms and no GCF, the only way that that can factor is by grouping. So I'm going to group the first 2, group the second 2. GCF of the first group is x squared, leaves me with x plus 6. So that means my second parenthesis also has to be x plus 6. Work backward. What do you multiply x by to get negative 4x? And fill it in, negative 4. So now, fronts give you your first parenthesis, x squared minus 4, and your second parenthesis is x plus 6. Now, this is a difference of squares. This factors further. It's x plus 2 times x minus 2. The x plus 6 doesn't factor further, so bring it down. Now, we are solving, not just factoring. So when I set each of those equal to 0, this one gives me x equals negative 2. This one gives me x equals positive 2. And this one gives me x equals negative 6. So that is how I come up with my 3 solutions there. On number 6, there is no GCF. And if I check for PST, square roots do come out evenly, but the middle term isn't right. That middle would have to be negative 6. So this is going to be factors that add. So I'm looking for what multiplies to 9 and adds to negative 10. So that would be negative 9 and negative 1. So on factors that add, remember we just fill the answers right into the parenthesis. It's not split the middle. So minus 9 goes in the first one, minus 1 goes in the second one. Be careful. A common mistake here is to forget that this was x to the 4th. These have to be x squareds in order to get back to x to the fourth. If you just put x, you're going to be missing the correct solutions. Both of these are a difference of squares. So this one factors further, and so does this one. So you end up with your final factored answer having 4 parentheses, so 4 things to set equal to 0. If x plus 3 equals 0, that means x is negative 3. This one would give me x equals positive 3. This gives me x equals negative 1, and that one gives me x equals positive 1. So 4 solutions there. Number 7 and 8, long division. So when I am long dividing, I need to set up my little bar. Dividend is the first one. It goes on the inside. I check. I started with x squared. Next come my x's. Next come my constants. So that has everything I need. X plus 1 on the outside. So you ask yourself, what do I multiply x by to get x squared? X is what I multiply by. So write that answer over top of its like term, which would be 3x. After you write something on top, then you multiply it. So multiply this x times the x plus 1. X times x is x squared. X times 1 is 1x. After you multiply, you change the signs and add. So change this sign, and add the column. These drop out. This gives me 2x. Then bring down my next term and repeat. What do I multiply x by to get 2x? I multiply by 2. So now I actually do that. 2 times x is 2x. 2 times 1 is 2. Then change the signs, minus, minus, and add. Negative 6 plus negative 2 is negative 8. Now I'm out of space, and there's nothing I can multiply x by to get negative 8, which means this negative 8 is my remainder. When we write it as a fraction. The numerator is whatever the remainder was. The denominator is your divisor here, which is x plus 1. All right, let's try that again. So set up my little box. I'm going to write smaller this time. 8x squared minus 6x plus 1, 2x minus 3. So what do you multiply 2x by to get 8x squared? Well, 2 times 4 gives me the 8, and x times x gives me x squared. So 4x, I lined it up over its like term. So now I multiply. 4x times 2x is 8x squared. 4x times negative 3 is negative 12x. So now after I multiply, change the signs and add the column. These cancel. That gives you 6x. Bring down my next term. Now repeat. What do you multiply 2x by to get 6x? You'd multiply by 3. So record that. Now multiply. 3 times 2x is 6x. 3 times negative 3 is negative 6. Or I said negative 6. I wrote negative 9, which is what's really correct. So now after I multiply, change the signs and add. So change the sign, and now these cancel. This gives me 10. I can't multiply anything by 2x to get 10, so 10's my remainder. So plus 10 over my denominator, which was 2x minus 3. So this is my answer there. Oops, I forgot to kind of box in my answer on the first one. There we go. All right, next up, synthetic division. So remember on synthetic division, when they give you a factor, what you're dividing by, you have to change the sign for the box. So this box is going to be positive 4. My coefficients, the cubed coefficient is 2, the squared is negative 7, the linear is negative 1, and my constant is negative 12. So set it up like so. Bring down my first term of 2. So now multiply. Box times the bottom would give me 8. Then add the column, which gives me 1. Box times the bottom is 4. Now add the column, 3. 4 times 3 is 12. Now add the column, which gives me 0. Do not forget that this is not your answer. You have to write your answer as a polynomial. So when I look here, my original was cubic, so that means this represents the quadratic. So my answer is 2x squared. That's the linear, so plus x plus 3. There was no remainder, so that means this is my answer. Let's try that again. Change the sign for the box, so -3. Now, the x cubed coefficient is 1. The x squared coefficient, this is the first time I've been missing a degree. Remember, whenever you're missing a degree, whether in long division or synthetic division, you have to add a 0 as a placeholder. So since there was no x squared term, I put a 0 in. My linear term is -2, and my constant is 12. So now, bring down my 1. -3 times 1 is -3. Now add the column. -3 times -3 is +9. Add the column. -3 times 7 is -21. Add the column. -9. Do not forget to write the answer as a polynomial. My original was cubic again, so this is the quadratic term. So 1x squared minus 3x plus 7, and then plus my remainder, which is -9 over, and then x plus 3. All right. Given 1 0 of the polynomial function, find all of the real zeros. So they're telling us that f of -6 is 0. So that means they're saying -6 is one of your zeros. So if you have 1 0, synthetically divide it, you know it should come out right, and find the others. So copy my coefficients here, 1x cubed, 2x squared, -20x, 24. So bring down my 1, multiply, box times bottom is -6, add the column to get -4. Box times bottom would be +24, negative times a negative is a positive. Add the column to get 4, box times bottom is -24, remainder 0. Remember, if you don't get a remainder of 0 on these, you've done something incorrectly. All right, so now this represents my x squared minus 4x plus 4. So you're not done. You have to find the zeros, which means you have to solve this. So this one's pretty easy to solve because this happens to be factorable. That's a PST. So it factors into x minus 2 squared, which means if you set x minus 2 equal to 0, that it gives you x equals 2. Now, don't forget, I said this in class, I said it in previous notes. X equals 2 isn't the only 0. You have to list this one too. So don't forget it. X equals -6 also. All right, let's try that again. So here we're given that 5 is a 0. So put that in our box. 3x cubed, -16x squared, +3x, +10 are my coefficients. So bring down my 3. Box times the bottom is 15. Add the column to get -1. Box times the bottom gives you -5. Add to get -2. Box times the bottom gives you -10. Remainder is 0, so I know that I have done that correctly. And remember, this means something. I have 3x squared minus x minus 2 that I have to solve. Now, this one is factorable. It's a split the middle. You're looking for what multiplies to -6 and adds to -1, which would be -3, +2. So split the middle term into -3x plus 2x, and then factor it by grouping. So GCF of 3x, x minus 1, x minus 1, and in the middle here should be a plus 2, because remember, if I distribute this back out, I should get the step above. So this factors into 3x plus 2. Oops, my pen went a little crazy there. That's from these ones. And then x minus 1. So if I set each of those equal to 0, this one, people always mess this one up because they try to do it in their head and forget which one they're doing. You subtract the 2 first, then divide by 3. So it's negative 2/3. This gives me x equals 1, and then my original, x equals 5. So there they are. All right, 13, list the possible rational zeros. This is the rational zero theorem. So this is the P and Q. So you're doing factors of the constant, which is 8, over factors of the leading coefficient, which is 3. So P over Q, and it's factors of 8. So the factors of 8, you've got 1 and 8, the plus and the minus, and 2 and 4. So those are your P values. Your Q values, the factors of 3 are 1 and 3. So to get my possible rationals here, I have to divide each numerator by each denominator. So 1 over 1 is 1. 1 over 3 is 1/3. 8 over 1, and then 8 over 3. 2 over 1, and then 2 over 3. Finally, 4 over 1, and 4 over 3. So those are my possible rational zeros. It doesn't ask you to find the zeros, so you don't need to solve anything. This is just using the rational zero theorem. All right, last ones. These ones we are finding all real zeros. So remember that the steps on this is list your possibles, then graph, show me your sketch. Because when you graph it, it narrows down the list. Then use synthetic division to get to a quadratic. So sometimes you have to do synthetic division once, sometimes you have to do it twice. But you have to get it to a quadratic, and then you can solve the quadratic to find the other zeros. So following these steps here, first I'm going to list my possibles. So that's exactly what I did in number 13. So factors of 6 are plus and minus 1, plus and minus 6, plus and minus 2, plus and minus 3. Factors of 8, plus and minus 1, plus and minus 8, plus and minus 2, and plus and minus 4. That is an awful lot of possibles. And when we're just listing the possibles, it's not that big of a deal. But when we're going to be looking at all of these, this is probably too many to look at. But I can check within my graph of step 2 to see if indeed that might be in the list. So I'm going to go ahead and do step 2, which is to graph it in my graphing calculator. So in your graphing calculator, you need to punch in this function, 8x cubed minus 6x squared minus 23x plus 6. Remember that on this one, you don't have to be able to see the whole function. You only need to be able to see the zeros. So if it goes out of the standard window, that's okay. You don't have to adjust the window. Now, you certainly can, but you don't have to. So step 2 here, I just focus in on the zeros. And I see that it looks like it crosses a little before -2 maybe. And it looks something like this. It goes out of my window. And then it looks like it comes back in between like this, and then curves back around right there. So when I look at my graph, I can see 3 x-intercepts. I can see 3 zeros. However, of those 3, the only one that looks like it's not fractional is this one right here. So that one you want to write down, could that be that x equals 2? Now remember, they all need algebraic work. So just because it looks like 2 doesn't mean I have proved that it's 2. Algebraic work. So now I do synthetic division. That's my algebra. I take that 2 and the coefficients of my function, so 8x cubed, negative 6x squared, negative 23x, and positive 6, and I confirm it. So bring down my 8. 2 times 8 is 16. Add the column to get 10. 2 times 10 is 20. Add the column to get negative 3. 2 times negative 3 is negative 6. Add the column to get 0. So now, my original was a cubic, which means this represents a quadratic. So 8x squared plus 10x minus 3. So I don't know if this is factorable, but I can find out. If it is, it's going to be a split the middle. So I'd be looking for what multiplies to negative 24 and adds to 10. So I can get that if I do positive 12 and negative 2, which means this is going to be factorable. It's a split the middle. So I split that 10x into 12x and negative 2x. Bring down my other 2 terms and factor by grouping. So group here, group here. This GCF is 4x, gives me 2x plus 3, which means this in front is a negative 1 in order for this to be 2x plus 3. So that gives me 4x minus 1 times 2x plus 3. So when I solve that, my zeros, this one, you would add the 1 and then divide by 4. So that would give me x equals 1/4. This one, subtract the 3 and then divide by the 2, so negative 3/2. Do not forget to list the one that you confirmed with the synthetic division. So there's 3 here, 1/4, 2, and negative 3/2. All right, last one. Same steps. List my possibles. So factors of 6, plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6. The leading coefficient is just a 1. So that means positive and negative 1, 2, 3, and 6 are my possible rational zeros. So if it crosses and is not irrational, it has to be one of those 8 things. So I look, I'm going to graph this in my graphing calculator, so punch in this function and graph it. Again, doesn't have to be a perfect graph. But when I draw it, it looks something like this. And so I can see 4 zeros on there. 2 of them look like they might be on exact points. This one is definitely between. I don't know what that is. This one's definitely between. But this one right here looks like it could be x equals 1. This one over here looks like it could be x equals negative 3. Remember, when you confirm with your synthetic division, it does not matter which one of those you start with, negative 3 or 1. I usually go from left to right, so I'm going to start with the negative 3. My coefficients, 1x to the fourth, 2x cubed, negative 5x squared, negative 4x, and 6. So bring it down. Box times bottom is negative 3. Adding the column gives me negative 1. Box times bottom gives me positive 3. Adding the column gives me negative 2. Box times bottom is 6. Add the column to get 2. Negative 3 times 2 is negative 6, which means I have remainder 0 here. Now, my original here was quartic, which means, remember, quartic needs double synthetic division. So, that means now take the other one, which was 1, and do synthetic division again with the answer line. You don't start over at the original, you use the answer line. So now bring down my 1. 1 times 1 is 1. 0, 0, negative 2, negative 2, 0. So now it's a quadratic. That's why I have to do double synthetic, because I need it to be a quadratic. This right here would only be a cubic. So this gives me x squared plus 0x, so minus 2, equals 0. That one is super easy to solve as a quadratic, even easier than the factoring here, because this one you can solve with square roots. Add the 2, and then take the square root on both sides. Just don't forget the plus or minus. Plus or minus radical 2 from this, and then don't forget to list the ones you confirmed synthetically. X equals 1, and x equals negative 3, which of course matches our lovely answer down here. All right, so hopefully if you were confused on some of those problems, the explanation helps. Study by doing, practice more problems on the ones you missed, and hopefully you will do well.